Hi, I'm Daz. In front of me I have a Rotel RX202 Mark II. I was going through some old photographs and I happened to find a photograph with this in, and it reminded me it was stored in the loft. It used to belong to a friend of mine who gave it to me many years ago. I believe it's been stored for, I think, about 18 years. It's the last time it's been switched on, and I thought, well, since I'm interested in vintage audio again, perhaps I might dig it out and have a look. When it was stored, it wasn't working perfectly at the time, so I'm minded that it might need recapping maybe. I think it dates 76, 77, something like that. I'll look it up and try and put it in the description, but it's not in the best condition. It's a little scratched. It's got one of those damn labels that the BBC sent out in the 70s. Tell you where all the new stations were, and I believe that's what that is there. I'm missing a few bits, unfortunately. Looking underneath, there's only 2 screws holding it in, and I seem to be missing the feet. I must have put this foam here and used that to support it at the time. Notice it's made in Taiwan. So I think I might well try and power it up, but I'm a little dubious because this only has loudspeaker fuses. It's a split power supply type amplifier, i.e. it has a positive and negative supply and a transistor on each one to drive the speaker either positive or negative. As I said, there's only fuses on the output, so I'm a little concerned that there isn't much speaker protection as regards to DC on it. But I think it would be nice to take the lid off now and just have a quick look inside and see what sort of condition it's in. So just looking around the back, you can see it has a pair of DIN sockets as well as the RCA or phono sockets. There's an input here for AM aerial and FM 75, 300 and standard British type TV plug. It can drive 4 sets, 4 speakers. It looks like there's a resistor behind there. Here's the fuses for the speaker. The cover's missing, I never had that. And here's the speaker outlets. So just having a quick look. If I tip it up for you, so we'll just have a quick look in here, see where things are. Immediately, probably won't show up on the video because I'm not zoomed in, but I could zoom in later. There's some corrosion on this preset, which isn't too good. So here is the FM front end. There's the tuning capacitor, the ferrite rod. This, I believe, is the phono amplifier. This will be the IF section here. Here's the audio amplifier proper. There's some TO220 transistors, smoothing capacitors and rectification. More smoothing for the other parts. Mains transformer. It's fairly deep. You might not be able to see it on this video very well, but it is quite deep. There's a fuse there. I believe that one is for the lamps. There's a pair of fuses there. I think that's for the input to the 2 main smoothing capacitors. I can see 7636 on those 2 capacitors. So I presume that's approximately around where it was made then, 76 or 77. You can see a sticker here which seems to indicate that somebody has repaired this already. So yep, that's the basic internals of what we've got of the Rotel. Right, just having a quick look close up here. Someone for some reason has disconnected the leads to the DIN socket for the phono. I have no idea why that is. This is the preset. I think it's the bias preset here. It looks, well, corroded for some reason, so I'm very tempted to turn that and put a bit of contact cleaner in before I even start, and just see how we get on. I'm using just a dummy load, and I've got my 2 DVMs monitoring each output of the amplifier, because as I was explaining to you before, Because this is a plus and minus supply amplifier, there is no capacitors on the output, so if something goes wrong it's going to chuck DC out at the speakers. So at this stage, as I bring it up gradually, I'm going to just leave resistors on and just have a look what the voltmeters are telling me. As I said, it hasn't been powered for 18 years, so I'm not quite sure what's going to happen here, but I've got the variac on it and the dim bulb, so I'm just going to bring it up gradually and just see what happens. Well, I'm busy here gradually raising the voltage, and I'm at 25% now. Some of the lamps on the front panel are glowing, and by the way, they're the fuse type lamps, which I guess are probably unobtainable now, but out of the 5 there are 3 in there, 2 are missing, and those are working, so that's something. Well, I've reached the steady heights of 230 volts, and nothing untoward seems to happen, and the speaker outputs are less than 30 millivolts, so that's not bad. So what I might do is attempt to connect some speakers next. Interesting thing I'm noting is tuning along the tuner, the signal meter is not moving at all. Now it could be it's got stuck over the years, it's got stuck, or it could mean that the tuner section isn't working, but well, the tuner is working, and it's the signal meter that's the problem, because the meter's moving as I tune across a strong signal. So unfortunately it looks like the meter's probably got stuck, I guess. That's a bit of a pain. I had to listen to it, and switching the balance, listening to the left and right speakers, and I just checked that they were reproducing the same. The audio is very, very different between the 2 channels, and I suspect that there is something wrong. One channel seems to lack bass and treble, but the bass and treble control are still functional, so I'm guessing probably there is something wrong with the amplifier. I've got it on mono, so it looks like I'm going to have to investigate what's causing that, but I suspect if I recap it first, that problem may disappear, but it might be worth just looking at it and just doing a sweep just to see what's happening. I'm just sitting here at the moment and just comparing the 2 channels with the signal generator and the oscilloscope. I know this has got a loudness type volume control on it, i.e. the volume control has a tap and the loudness control puts filtering on, but that's kind of interesting. When you turn the volume up, it sort of starts to miss track. I'm looking at 20 Hertz here at the moment, so I'm just sort of intrigued by that slightly. Again, about the same thing really at 1 kHz. I can't see a lot of difference. This is puzzling me because I can definitely hear a difference between the 2 channels, but we're not really showing much difference, are we? Okay, 10 kHz. Sort of showing the same thing. Not as pronounced though, I don't think. Just go up a bit. Let's try 20 kHz. It's used to me, I can't hear that high anymore, but odd. Although I seem to be hearing a difference in the audio between the 2. It's odd. I'm now wondering if it's something to do with the tuner, even though I had it in mono. This is the signal generator input, and this is the radio modulated with a signal in mono mode. So yeah, my ears weren't deceiving me when I said there was something a bit iffy about the radio output. There's a very big difference. To be honest with you, the audio input from the signal generator is a little bit amiss. I've also noticed some intermittent phase shift, but I've got a feeling that's just dirty contacts on the bass and treble controls. When I initially did the sweep, I had both controls in neutral, but I'm now suspicious of the controls. Obviously you've got an intermittent connection, you can end up with a phase shift between one channel and the other, because basically tone controls do cause a phase shift. Just having a look at the output and the scope again. Where we're looking right now is the output of the stereo decoder in the receiver, and I think you can see we're now level. So after the stereo decoder is a single transistor on each side with a pot between the emitters to adjust the stereo leakage, which is interesting. But looking at that, and the fact I'd also looked at the tape output, which I'll now show. So here we're looking at the tape output, which is basically directly connected to the two single transistor amplifiers, and you can see we've got a slight phase shift, I believe, and a difference in the amplitude. So I suspect that there's an issue around that amplifier. I might try recapping around it first and check the resistor values and just see where we go from there. Okay, with the coupling capacitors replaced and the stereo separation or stereo leakage capacitor replaced, we now appear to be in balance again, so that's good. So it was a leaky capacitor, or even the value's wrong. Let's have a look. That should be, yeah, 470 nanofarad. It's only 42 nanofarad, so that's the cause of the problem. I've elected to replace these 0.47s with film capacitors. Means they're quite small, so I've popped them in instead of electrolytics. These small electrolytics always seem to be a problem. I don't know why, but they just do. This is the section where I replaced the capacitors. You can see one of the transistors for the buffer for the stereo decoder, and the stereo decoder is the top left of the screen next to the blue capacitors. I've been through and recapped all the radio section now. You can see the blue and the red film capacitors, and checked the radio, and the radio sounds very, very nice now. Even with modern Optimod transmissions, it has a nice sound to it. So that's good progress so far. I'm now looking at the next part of the receiver to recap. This is the preamp board, and I need to get to the track side, obviously. In the way is the lamp part. This is what holds the filament lamps. I'm wondering about taking this off and I can get access to the track. The only thing is the tuning scale runs here, and I don't really fancy putting the soldering iron anywhere near that. Of course, the other alternative is to take the front panel off. So I'm not quite sure at this moment where to go from here on this one. Notice that the volume control is got bent. I don't know if you can see that. Not quite sure where to go on that one, so I might need to have a think whether I want to attempt to bend that back into shape. As you can see, I've removed the lamp part. There it is. Anyway, I've got some ideas about this lamp, so we'll go over that later. Anyway, I've got access to the preamp now, and the cord is out of the way up here, so hopefully I won't burn a hole through it now. Interesting, it's been interesting recapping. Main smoothing caps were rated at 25 volts. The supply rail is sitting at around 24.5 volts. That seems rather close to me, so I've gone for 40 volt caps. There's one or two others that were sitting a little bit on the high side, so I've gone up one range, i.e. 35 volts on those replacements. So now I'm going to just do the preamp now, and I should be completely recapped. I've been switching it on in between just to make sure everything's still functional, and it is, so that's good news. As you can see, I've popped the tuning meter out and gently pushed the pointer, and it's duly stuck there, so it's obviously got some problem. I sometimes find that if I just gently undo one of the little bearing screws, it'll release it enough, and it usually is okay. That's the bracket and the illumination lamp. I had to give a little tug on this bracket here to get the meter out. I don't know if it's glued in, the front part of it, but that's good enough for me to get at. I'll have a look and see if we can do something with it. Well, after a very careful adjustment of the bearing, I seem to have loosened the meter up enough now. It's not perfect, but it's moving. Now, I can't have a meter that doesn't move. You know how a sucker I am for meters on pieces of equipment. So. Just having a think about the lighting. I'll just pop the fuse holders out. I've not used lighting strips before, but that was the idea. But looking at the way the thread sticks out, etc., it's going to be a bit of a problem, because that's not going to sit flat, so I may have to put something else in there for it to sit on. But so I've been looking at the lighting situation. Here's where the lamps used to be, and hopefully if it focuses okay, you can see having a rummage in the shed, which I can hardly get into, another story. I found some of this metal bar and self-tapped in, and the lamps now fixed on, well, with their self-adhesive fixed on. There we go. You should be able to see that's warm white because the lighting in here is a higher colour temperature, but and I've got a similar thing for the meter, so that's what I'm going to do. Obviously this needs 12 volts, so what I was thinking was there's a circuit board here with the 2 amp fuse for the power supply, so I was thinking of just putting a voltage doubler on there and a resistor to limit the current. Those 2 lamps are only using about 110 milliamps at 12 volts, so you know that's just over a watt, isn't it? So it shouldn't be too bad. I won't need 2 big smoothing capacitors, but it certainly illuminates it okay. That doesn't look too bad. There's a slight colour difference, but yeah, I think that'll do the job nicely. Well, I think about telling you, I've got some new lighting on the bench now. I think you can see the 2 strips. They're higher CRI strip lamps, and also now on the ceiling, if I can get that far, I've got a LED strip lamp now. So what with using a new camcorder and new lighting, I think things will look a little bit different in this video. In fact, they'll be changing as we go along, but never mind, it's all part of the fun. Well, I've modded my board. I put a cut down there so I could use that as the ground rail. There's a couple of rectifiers. There's one giving negative, one giving positive. And on the other side I've got a 470 at 16 volt. That's the positive one, that's the negative, so I'm effectively making a plus and minus power supply. I get about 16 volts offload, so I've used 2 27 ohms in parallel, and that gives just under 12 volts on the string of LEDs, so it's reasonably neat. Just need to sleeve this up, and I've dropped the fuse to 1 amp, but yeah, that seems to work quite well. Well, I've got the LEDs in and finished the power supply, so you can see what it looks like. I've dimmed the lights in the workshop a bit, and yeah, it looks quite nice. The only thing I notice is I think the colour at the bottom looks slightly different. Perhaps more warm white strip would do, but it's not too bad. It's only using less than 2 watts to light up the scale, so that's a little bit of power saving on the transformer. Going back to the mystery of this DIN socket, my memory seems to tell me that the reason this was disconnected is because it was actually shorting the phono input. Now, I can't find any signs of conduction, but I've had this problem before when things have become suddenly conductive, whether it's the atmosphere they're in or something. So anyway, I've replaced it with a new one, and I'll go along those lines. That's what I seem to remember happened, but it was a bit of a mystery to open up and find the connections hanging off the phono, but that's what I think happened. While I've got the opportunity, I thought I'd just show you what happens when you turn the bias right down. There's the crossover distortion, and if I just gradually turn the bias up, you can see that little kink disappearing as I bring the bias up to where it should be. So there we go. So that's the effect of crossover distortion, because the transistors are not switched on hard enough to take into account the 0.6 volts that's needed to turn them on. So that's why you have the biasing. But yeah, I hope that demonstrates the effect of not being biased. That doesn't sound very nice either. I think you can probably see the meters, and you can see I've turned the bias right completely down. So I'm just going to gradually adjust that so that we've got some bias again. And as I expected, when you get close to what I need, ooh, that is very, very sensitive. So trying to get that to 15 millivolts, ooh, yeah, that's pretty difficult actually. So that's one done. And just twig the other one. And of course, there's a Zener diode right in the way. But just checking the mains voltage, 243, because that will affect it as well. As you can see, it's changing. So what I'll do is I'll leave this switched on for a little while and just come back and check it and readjust it, and see if that stays put. I've drawn a cut down diagram to try and explain what I was speaking about earlier about how this is a push-pull amplifier using split voltage supplies. So as you can see here, there's a plus 24 volt supply, a minus 24 volt supply, and a 0. So this is minus 24 to the 0, and that is plus 24 to the 0. And here you can see a transformer with a centre tap, and the centre tap is 0. And then you've got the normal 4 rectifiers to charge this capacitor positive and this one negative. Here's how it looked like if it was a battery. Now we've got 2 transistors on the output stage connected to the loudspeaker. This transistor here will pull it negative, so suck it in, and that one will push it positive or push the cone out. So obviously we can get our sine wave. These are both NPNs on this particular receiver, but I've seen a PNP and an NPN used. It doesn't really make much difference. The main point was, if one of these transistors failed, it will push DC through this loudspeaker. Hence why there's fuses on this one, and many other receivers have a DC monitor. So they monitor the average voltage, and if it goes away from 0, they will trigger a relay and cut the speaker off before any damage is done. The driver is a PNP and an NPN. This is the biasing circuit, which enables you to switch both transistors on continuously. You need to switch both transistors on, as I've previously explained in another video, to make sure that one of the transistors doesn't completely switch off before the other transistor does, because otherwise you end up with a little notch or a gap in your waveform, and that doesn't sound very nice. But I just hope that hopefully explains a little bit of how this works. And by the way, that is the driver transistor. When setting the bias, you need to make sure there's no audio going through, as of course, and these are the resistors here, the emitter resistors that I was measuring earlier to set the said bias current. Well, how do you like this? Whoops, I need to understand how this stand works, but this is my Bodget and Scarpa photography lamp I've just made. These are the remainder of the 90 colour rendering index LED strips I've got on the bench, so hopefully I can use this to get a bit more lighting. I had to use diodes, a couple of diodes, to cut the current down a little bit, because I've only got a 3.5 amp power supply, but I'm not complaining. So it's a brand new power supply. I found at car boot sale for just £1. Let's see if it completely whites out the camera. Oh yes, that's quite good, isn't it? Yeah, yeah, I like that. Oh, good. So hopefully that should help with some other photography in other rooms. Right, the amplifier's been on for quite some while now, so the readings are around about 15 millivolts, so I think I'll leave it there. The next decision to make is whether I do any alignment to the radio itself, but I don't think I'm going to at this stage. The radio seems pretty much aligned. I will need to use a distortion meter and an FM stereo generator, and I don't actually have one of those, so I will have to decide whether I'm going to do that or not. Perhaps it'll be another part if I do. Just looking at the bottom case, well, the wooden case now, something I've noticed is, I'll get this right, I don't know if you can just see there's a piece of papery, silvery thing there. Oh, I think another bit's just fallen off. That was located here with some staples, and that lines up to the preamplifier here, so I'm going to have to find something to replace that with and make sure it's damn well fixed, because we don't want it short circuiting on the PCB. I found this and thought, well, this might be suitable for that job. It was pretty difficult getting that foam off, but it has come off now. But I'm still trying to search in my spare parts for one of these. It's a little bit of an oddball, these washers with sort of, they've got little teeth in, and 4 feet of course as well. Well, I'm just seeing what I can do with the cabinet here. I've used some self-adhesive tape to put a new screen on the bottom because the other one sort of fell off. That sits under the phono amplifier. I've stuck some new feet on. They were also glued on as well as screwed on, so I found 4 period feet and I think they match quite well. As for the missing bit of metal here, I think I'll just go for a repair washer and that'll do the job. I'm going to have to be very careful putting this lid on not to pull that screening tin foil off, but there we go. I'm not doing any more to it for the moment. Definitely not going to do RF alignment until I've got a FM stereo generator, so that'll do for now. At least it's in a lot better working condition than it was previously. Well, I've got it back together now, and everything seems to be working okay. I've just played some music using an FM modulator to see how it sounds. High filter, loudness. It sounds nice, and I've still got the bulb as the stereo indicator, but I could always change that later, so I think that'll do for now. Well, here's my leftover parts, and that's most of the electrolytics, I think. Well, all the electrolytics done. A lot of them are showing double the value. I suspect that's because they're leaking heavily. Might be worth just doing a little leakage test perhaps. Well, I've just got some of the capacitors from the unit here. I'm just trying to make sure that's readable. Yes, it is. That's a 47 microfarad and it's reading 82. The ESR's good. If I just compare that with a good capacitor, just make sure it's discharged first. Yeah, it's reading 47. The ESR isn't much lower. So what I'll do now is I'll just do some leakage tests just to see in my mind whether it's increased leakage that's causing the reading or something's actually happened physically inside the capacitor. Okay, so I've got my meter rigged up to the power supply here with a current limiting resistor as well, because when I connect this capacitor up it's going to cause a spike, and because there's a capacitor on the output of the power pack, my meter probably won't like that very much. But anyway, here's the good capacitor. If I just pop that on, and well, the current is what, let's see how many digits, that's about just under a microamp of leakage. That's very, very little, isn't it, on the new capacitor? So I've just popped the old capacitor in and just see what that one reads. Okay, so that is more leaky, but in a transistor circuit, which is always low impedance really, that's a couple of microamps, so it's not much more leaky. So I don't think the leakage is accounting for the increased capacitance in this case, and there must be another reason, but that's an interesting little experiment. By the way, that's 25 volt capacitor and we're running at about 14.8. I think you can, oh, you can't quite see the meter, but it's 14.8 volts, and yeah, it's fallen, so it's not that leaky. But it's just interesting to see if the capacitors were leaky. So I haven't really got an explanation, as I said, why the capacitance has doubled. It must be some other reason.